Hey, I might go today. We're definitely talk about MySQL and databases. I think I'll go through a little of this MVC architecture as well and open up some actually. Do I have an example set up? Decision tree has a model and a view. I guess that'll do for us. Or else you'd have to watch me just moving files around. You know what? Maybe I can. Let me not do that right now. Let's get through MySQL first, but maybe I will get a full MVC architecture example. You know what? I'll just go to GitHub and do it. Get a full MVC architecture up and running, and show you how that works in action through one of the old homeworks, through the jumper homework. I'll show you how that works. Uh, all right, we're starting this MMO architecture week. We have to clean up some MySQL from last time. And hey, Toadfish. We'll clean up some MySQL from last time, maybe review a little MVC because I really rushed through it at the end of last lecture. So we'll talk about that a bit. And we'll just start talking about some MMO architectures. And we have the big question this week of, given everything that we know right now, how would we build an MMO? How do we have one server that's going to host effectively an unlimited number of users, all interacting with each other, limited by, of course, our hardware limitations and the network limitations. So how would we build such an app? And there probably won't be many slides. There's definitely not slides today, and probably not at least one of these 2 days, Wednesday and Friday. But I might have one depending on which apps I want to talk about, which MMO I want to use specifically for an example. I have a handful of them that I want to use. Some of them I have slides prepared for, some of them I don't. So depending on which one I end up using as the example, we'll determine how many slides. But don't expect too many slides for this week. Um, so, any it's going to ask any questions. For some reason um, that flashed back. Like, this is the point where I ask for questions. I don't really do that online though. Yeah, thanks, Linux. My daughter made this shirt. They were doing tie dye is one of their activities for a day. While I'm upstairs working, and they made tie dye shirts. My one daughter made one for me. Uh, so let's just talk about MySQL and then probably revisit MVC, and then I want to talk about some MySQL setup with some of the apps that are deployed for this. I'll use the chat app specifically, and we can talk about some little differences set up for those of you who want to test features for the project contributions, but without running a local MySQL instance. In the slides, we'll talk about local MySQL instance, and then I'll use that chat app as an example. It has the same infrastructure as the project contribution apps, and I'll talk about how MySQL works with that one. Jesse SQL, return of Jesse. Uh, yeah, the viewers, it looks like that's off again. I can see how many are in chat. We have way more than 13. But let's not have another conversation about the view count. That's not too interesting. So let's go back to our MMO architecture. We've talked about all of this aspect of it, our network architecture, our app architecture, however you wanna view this. We will eventually be talking about an MMO, just to show you how an MMO can work, how we can get one of those up and running. And depending on your definition, technically you could call either the project contribution projects MMOs. You can have a lot of users all using the app at the same time, but usually we think of games, thinking MMOs more synonymous like that. So let's talk about this part though: how to set up a MySQL database and how to get our persistent storage in here without having to rely on file I/O. So let's discuss that. So you've seen SQLite as long as you've taken 115 here at UB. You've seen SQLite in 115. So what's the difference between SQLite and MySQL? They both are SQL servers. But let's talk about the difference a bit. excuse me, and talk about why we're even talking about MySQL when we already have SQLite. We already have a SQL database solution. Why talk about another one? Oops, hit my wheel. So MySQL is a full database server, and this is typically how databases work. They are servers, and they're running as a separate process on your machine, or potentially on a completely different machine. Databases are set up like this. This is the typical standard setup, is that you have a database running potentially on a different machine, and then use network technologies, use TCP connections to be able to connect to that database and send it queries and statements. In our case, we're going to send it SQL statements and queries that the database will execute, and that happens over a network. We make a network connection, send the statement. The database is a whole separate process that runs, processes that statement or query, and then sends us back the results over that network connection. So usually, for our purposes in coursework, our apps are not large enough that they don't fit on a single machine. So usually we have MySQL running on the same machine, but as our app, but we're still using network technologies to connect to it. Nothing changes with that. So in our code, we're going to have to make a network connection to the database. Even if it's on localhost, we just connect to the same machine. SQLite removes all of that networking. So even when it's set up, databases are set up to be just naturally networked. SQLite says, you know what, let's simplify things, remove all the networking, and just run, and just save a file, and just get rid of all the overhead of MySQL. So SQLite is a very simplified way to store some information, which is why it's suitable for 115. We can talk about SQL without having to mess with networking technologies in that sense. We don't have to add too much extra to it. So SQLite really simplifies that, runs on the same machine. It works with simple file I/O. You can see your database file when you use SQLite. It's right in that same directory as your project. And it's really great for a few things. Prototyping, for one. If you just want to test your app without running a full MySQL instance, SQLite's there for you. If you don't have a lot of space and a lot of resources where you're not spinning up an entire server, so embedded devices, embedded systems, and mobile apps, you have a lot of restrictions, and you know your database is running on the same machine. You don't really have an option. You don't have too much of an option. You're not going to tell each person who buys an Android phone, if they want to use your app, they have to go get a database. So for local storage on phones, that's common. But MySQL is more of the standard solution. Like you want a SQL database, MySQL, Postgres, a few others. But running a full database server is usually what we want to do. So MySQL is a software. You have to download it, install it, and run it. If you try to run any of my database examples in the repo, if you run that code, you're going to get an error, and it's going to say couldn't connect, something to the effect of couldn't connect to MySQL. Database refused connection, or database not responsive, or something like that. You're going to get some error like that because MySQL, if you didn't download it, install it, and run it, it's not running on your machine. So there's no server there to connect to. So in my database code and any of the examples I have in the repo, there's a line in there that says connect to localhost port 3306. I don't specify the port because that's the default port, but I say connect to the MySQL server that's running on localhost, which means this machine. Whatever machine this software is running on, use that same host. So I'm saying connect to that. So if your machine, if you're running this on your laptop and you don't have MySQL running, you're going to get that error. So MySQL is software. You go to the internet, go to mysql.com or whatever it is. Go to MySQL, go to their website, download their software, install it, and have it running in the background as a separate process on your machine. When that's ran and installed, it'll be listening on port 3306 by default. This is the port that MySQL said, that's our port. We're going to run all of our stuff on that port. Just like our WebSocket server is running on port 8080, we said we're going to use that port for development, which is a common development port. We're going to run on 8080. MySQL said all of our stuff is going to run on 3306. So it's going to run, listen for connections on 3306. And then in our code, we're going to install a library that's going to allow us to connect to that database. So we're going to use what's called the JDBC, the Java Database Connectivity Library. We're going to use this, or interface. We're going to use this to be able to connect to that database. So Java has a way to connect to, a common way to connect to any database. And we're going to need our MySQL drivers for that to be able to use that protocol to be able to connect to this MySQL database. So this is something we have to go into Maven for. It's already in Maven if you've been using the one from the repo. And get the MySQL driver. That has to be installed before you can connect to this database with JDBC. So this driver is taking that networked connection. It's making that network connection. It's speaking MySQL's language. It's making those connections and handling all of that communication for us. So when we interact with the database, we're interacting with this driver, and then we can think in SQL statements, and we can send it SQL statements. It's going to take those SQL statements and convert them into network traffic, go to the TCP connection, send those statements to the database in the exact format and protocol that it's expecting, and then we can communicate with this database server through those drivers without having to think of the low-level details of how is this connection made, what network technologies are being used, and all that stuff. So we're going to use the driver to be able to connect to that database. If you have a different database running, if you want to test out Postgres or MongoDB, something like that, you would download the drivers for that database and then connect to that database that way. So in the code, after we have MySQL running, so if you want to test the MySQL code in the repo, you'll download MySQL, install it, run it. Once it's running and you have Maven updated, or if you've used the Maven file from the repo, you've had this driver installed all along, you've had it in every project that you've been using. You just didn't know what it was or care what it was earlier. But once you do that, then you can start running that code and connect to that MySQL database and have persistent storage in your app. You can run one of those apps. You know what? We can have the whole repo. You know what? Oh, no. I don't have. Never mind. Let me bail out of that one. I actually don't have MySQL running right now on this machine. I was going to run one of those and show you. I could show you the error, I suppose. It's not too exciting, though. So once you have MySQL running, you have the driver installed, you can go to the code and start using all this software that we've installed, that we're using to connect to the database and start sending it SQL queries. So the first thing we have to do is make that connection. This is a networked connection. We have to provide it a URL using the JDBC MySQL protocol. We're going to connect to localhost because this database is running on the same machine. Assuming that's the use case, I'm going to specify the database name. I'm going to use the default database name MySQL, and then optional query string if you need to set extra parameters. For some reason on my Mac, and I've only seen this on my Mac, but I left it here just in case somebody else has the same issue. We can get around that issue. If I don't specify the time zone, it gives me an error and I can't connect to it. So I'm specifying the time zone. Maybe it's something I didn't set up during the install process or something. I don't know. But just so you don't come across the same issue for whatever caused it, specify the time zone. But usually you can get rid of this and not specify the time zone. I don't have that there in the project contribution projects. So sometimes optional, but I want to leave it there in the slide just to make sure if somebody comes across that issue, you got the solution right here. Then we're going to specify the username and password. When you install MySQL, it'll ask you to set up a root password. So the SQL, when you install, by default, will have a user named root with root access. It has access to absolutely everything in the database. And it'll ask you to set up a password for that. So we're going to set up some password during install and then match that password in our code. So the password that we put here has to match the one that we used during setup. So unless you chose the password 1234567 when you installed MySQL, this code isn't going to run. You're going to get a connection refused from the database because you're not authenticated to use that database. And finally, once we have our URL, username, and password, we're going to use this driver manager get connection, give it those 3 pieces of information, and if everything goes well, if we have everything set up properly, we should get our database connection out of that. And then we can use that connection to start sending the SQL statements and start interacting with our database. So there's one big caution here, is right now what I have on screen is a password that's hard-coded to be in this code. I put a password right in code. Whenever we're doing this, if we're ever doing this, which I'd argue we shouldn't really ever do this, is we have a very big security risk here potentially. Why would the connection have to be var? It doesn't. I don't know why I use var. I just for some reason typed var there instead of val. But the connection could be val. I think, actually thinking back, I think I did var connection and then set this equal to an underscore and then put the connection, establishing the connection inside of a method. I think I had it set up as that at one point. Then I just never changed it to val once I changed the way I was doing this. So when we have this password like this, if this is a password you're using in production, you never, ever, ever want to check this into version control. You never want to check this password into Git if you have this somewhere in your repo, somewhere in your code. Never push that into version control unless you're going to change it when you're deployed on the server. So whoever has access to that repo, so think of the project contribution projects. I need a shorter way to say that. Think of the PCPs. It doesn't work. Think of the projects. I'll just say projects. So think of the projects you're working on right now. If you push a password into that database, you create a pull request, you say, I added some database functionality, and somewhere in there you have hard-coded the password. And I have this app deployed. It's out there on the internet where everybody can use it. Well, now everybody can go to that deployment. They have the password for the database, and they could potentially use that to gain access to the database. They can try to create this connection, just replace localhost with officehours.cscsoftware.com and try to connect to that database, and then hopefully we're denying outside access, remote access to that database. But it's a very strong potential security risk, and also even if you're not worried about outside attackers, checking into version control. Every dev on your team, if it's a private repo, private to your company, every dev on the team has access to that password, and they might have access to the server as well. They might have SSH access to the production server. They could go into the database and just see everything. They have full access. They can change. They can access personal information. They can give themselves admin access. They can do all that crazy stuff. So you'd have to trust everybody with that password. So as a general rule of thumb, password should be need to know access. Only people who need that password to do their job should have access to that password. So a lot of caution here. Just be very careful whenever you're typing out a password that has to be stored in plain text. Just be careful about who has access to that password. And it's common to store these passwords in environment variables, so they're not in the code themselves. Environment variables are set at the operating system level. Set those environment variables when you deploy to production. Set those variables, and then there's never a default password in your code, so you're not accidentally sharing. That password with everyone who has access to that code. A lot of software, a lot of open source software out there will have default passwords. So like MySQL, when you install it, it'll make you create your own password. but not all software does this. If you use open source software, some of them are set up like this, where they'll just have some default password, or maybe a router you buy. Routers commonly have some default password. You can look them up online and be able to access anyone's router who's using the default password. Don't make this mistake. Always change those passwords if you're using someone else's software. And if you're releasing software like that, I'd say don't have a default password. If you've heard of the Equifax leak, this was one of the big contributors to that. Equifax, they were using some open source software to manage their data. They were networked features, so some members of their team could access them. They could work remotely. They could access these features. If something breaks, the sysadmin could log on from home and fix that thing quickly. They had these networked apps with access to critical information. And from what I understand of it, anyway, I might have some details wrong. I'll put out that disclaimer. They just didn't change the default passwords. So they used the default passwords, and just some dev who was, bored one day or whatever, they were poking around and said, let me just try to, looks like Equifax is using this open source software. Let me just try the default password. And then all of a sudden they had access to everything. Like it was the silliest thing. So make sure you're changing those passwords. There's a lot of caution here. Security is one of the most important things that we do. If you build the world's greatest app, deploy it, and it's absolutely wonderful, but it has a huge security vulnerability like Equifax had, it's worthless. You're doing more damage to the world than good at that point. And it's a really simple thing to fix. And it's a common thing to just say, well, nobody's going to attack my site. There are actually bots out there that'll scan IP addresses and look for these kinds of things. They'll look for that specific software. They'll have lists of things to look for in their scripts and just ping different IPs. Just constantly scan the internet for these vulnerabilities. So somebody doesn't have to specifically be attacking you. They just have to randomly find you through one of their scripts. And then some human gets an alert, hey, here's this IP address with this vulnerability. And then the human can go in there and try to do some damage or whatever they're trying to do. Probably post ads on your site or something stupid. But there are bots looking for this, so don't think that you're safe just because your app doesn't have a lot of users or something. That's not a good foundation for security, for having vulnerabilities. The bots are looking for this stuff. Okay, so once we're connected to a SQL server, we can start sending it statements. We're going to access that connection that we have, that we stored in that connection variable. We're going to make a statement and execute it. So there's a tiny bit of extra syntax here, but to send a SQL query, create a statement, and execute that statement with the SQL query that you want. So here I'm going to create a table. If that was September. It was 2017 already. It seems like it was so recent. But we're going to create a table if it doesn't exist. This is something I'm running on server startup. I'm going to call this command. If I just have create table and that table already exists, the program crashes. Don't ask me why that's the default behavior, but it just crashes. Everything blows up. But if you do create table if not exists, then it's only going to create that table if it doesn't exist. So the first time I ever start up this server, it's going to create that table, and then it's not going to create it again. We're going to create a table named players, and we have two fields, username and points, text and int. And all this should be familiar from 1.15 once we get to the actual SQL statements. Making the connection is really the big new thing that we're talking about with MySQL. Installing MySQL, getting it up and running, and then making that connection. Those are the big new things that we're talking about. But this, you've probably seen an almost identical statement in 1.15. When we're using prepared statements, which we always do, never concatenate into a SQL statement. Again, something I'm sure you've heard in CSE 1.15. When we're inserting into the database and say we're entering two values that were entered by one of our users, for this case, probably the points they didn't enter, but at some point they chose their username. We're going to write our SQL command and put question marks in place of each of the values that we want to splice into this thing. Now we could, but we never will, do string concatenation here. We could have our double quote plus plus whatever the user typed in for their name, plus double quote, and string concatenate those right into our SQL statement. As you know, from 115, we have a huge security risk there that the user can then inject their own SQL statements into this statement and just start destroying everything or taking anything, whatever they want to do. They have control at that point. As soon as you're splicing in their whatever they entered into the database, into the query. So we're going to use our prepared statements with question marks and then set the values with indices starting at 1. Don't ask me. Indices start at 1 instead of 0 here. So setting the first value in the prepared statement is the first question mark. The second one is going to be the second. 2 is going to be the second question mark. Should we worry about the security risks when doing the clicker expansion? I mean, yeah, you should always. I won't grade based on that, if that's what you're asking. I probably should. I should add that now that you mention it for next semester. But you're just being irresponsible if you're not doing that. You're behaving like someone who shouldn't get a job, I'll say. If you're like, well, I technically don't have to worry about security here, so I'm not. You should get the practice. And this, I'd say, is about as much work as doing it insecurely. So, yeah, I'd say it is something you should worry about. But if all you're worried about is passing the class, then no, you don't really have to, I guess. Yeah, there's never a time when you wouldn't worry about security. Get in the habit. Get in the habit of only doing things in a secure way. Please. I might be using software you write at some point in time. I don't want to be using insecure software. Please get in the habit of that. Can you overwrite a value in a table if it exists? Yes. You use the update in a table where some value equals some other value. Can we have a demo that shows how to set up MySQL? Maybe I can do that during Q&A. Maybe I'll install MySQL on this machine and show that process. But it's different. It's something I don't really want to take lecture time doing because it's different on every operating system. It's different based on your platform. So anything I do isn't going to benefit everybody. Def get MySQL index n+1. So we're going to add our values and we're going to specify the types here. So now when we use a prepared statement, instead of treating this as something that's going to be part of the statement itself, SQL is going to treat that as a literal string. So we give it some string literal, splice it in here, and MySQL, even if that string contains some SQL syntax, it will not interpret that as part of the SQL statement. It will interpret that as strictly a value that's being inserted into a table. When we use our prepared statements, you cannot have SQL syntax interpreted as part of the SQL statement, which you could do if you use string concatenation. So string concatenation is going to allow the attacker to do whatever they want. Prepared statement like this, they're not allowed to do what they want. And then finally, we still have to execute the statement like we did before, except we're executing a prepared statement instead of executing a statement that we provide at the time of execution. I'm installing it now. Just kind of clicking through the installer. Yeah, just clicking through the installer and hope it works. Yeah, I know. So I used to require MySQL. We had a lab where you had to demo MySQL up and running and everything. And everyone just mashes through the... Oops. I'm going to advance slide. Actually, I do want to advance one. And everyone just mashes through the install process, just clicks around all randomly and shit. And then they get to lab, and half of the students, it doesn't work because they didn't pay attention to anything that happened during the install. And it's just a nightmare to the point where I don't require installing MySQL anymore because everyone does that. They just click and hope, and then when it doesn't work, they come to office hours and cry. This is so hard. Like, just read the things it's telling you. Because one of the things everyone clicks through is setting the password, and that password has to match your code, and or they're downloading the 32-bit version. They have a 64-bit machine. That was a common problem, which I had hoped wasn't going to be a problem, but it was. Just a lot of things go wrong. So I talked about a lot of this on the previous slide, but if you're not using prepared statements, what's the worst that can happen? Well, somebody could add this. They're going to add a single quote, which ends in a semicolon, which ends whatever statement you were preparing. So, by the way, this is going to be in single quotes or double quotes, potentially. Eventually, if you string concatenate, you would have to add those quotes in yourself to say this is a string. We're defining it as a string here, so the quotes are going to be added for us. But you would have your quote to specify the value. So what the attacker is going to do is put a closed quote that ends the string that they were specifying to insert into the table, and then a semicolon that ends the statement that was being prepared. So that statement is still valid syntax, or if they know we're using parentheses like that, they might have a closed parenthesis as well to close that part of the statement. But whatever they have to do to end whatever statement you were trying to do, and then write their own statement after that, and maybe they just want to destroy the world, watch the world burn, and completely drop a table, and just delete all the data there. This is deleting a table. Delete that entire table. So this is something they could do. But what if they want to do something a little more malicious? Maybe they want to do select star from users and try to get usernames and passwords, hopefully hashed and salted passwords. But what if they want to get some user information? What if they want to get credit card information, which can't be protected the same way we protect passwords? They can get credit card information. If you ever notice that whenever there's a big data breach, all these credit card numbers are released. All these social security numbers are released. All this stuff was attacked and compromised. Never do you see passwords were compromised, user accounts were compromised, and people are logging in, attackers are logging in as everybody else. That doesn't happen because we're really good at securing passwords, but we don't have a good way of securing credit cards and keeping those private on a database, and really any other information. Passwords we got down though. So get all those credit card information, credit card numbers. Maybe they want to set their own user status to admin so they have full access to the website. All kinds of stuff they can do once they can inject their own SQL statements into your database queries. And this is still, even though it's so easy to protect against, everyone should be doing this. You learn this in freshman semester, twice in your freshman year. It's still the most common successful attack. There's still presumably devs out there not doing this. And also there are ways to access a SQL database, to inject SQL even with prepared statements. So there is a cat and mouse game going on where either side is always trying to stay ahead of the other. And there are still successful attacks even with prepared statements that I'm not familiar with, but I'm told it's possible. Fake out the attackers by using lots of parentheses. So one of the concerns is you should always assume that the attacker has your code, and that's often the case. Think of all the open source software that is out there. The attackers get to look through the code. So if they have all the code and access to your public-facing website, can they execute a successful attack? That should be your level. That should be your standard for security. If they have access to all of my code, could they write an ejection attack? Which is usually the case. You're talking about security through obscurity, which is so bad that it has its own rhyme to it that people say. It's basically its own meme. Security through obscurity is not security at all. Like if you invent your own hash function, for example, nobody's going to crack it because they don't know what that hash function is. But it's not good practice at all. Because once they have your code and realize how weak your hash function is, you're no good. It's no good. Yeah, MySQL office hours last semester. That was not a fun time. Um, and the big problem was, what got me thinking during that time is debugging all these MySQL install issues had nothing to do with the actual content of the course that I'm trying to convey. So I rearranged some things, specifically said these 5 learning objectives. This is what I want you to need you to have out of this course. And then I focused all the assignments and all the structure of everything, of most things at least, to focus on those 5 learning objectives. And MySQL just doesn't fit into any of those 5 learning objectives. So all the MySQL requirements got cut. But I still want to talk about it, especially because I use it in some of the code that I give you. I still definitely want to talk about it during these 3 weeks where I'm not covering any learning objective content. So, all right. So when we want to get data out of the database, the other side of things, we saw how to create a table and insert information into it. When we want to pull data out of it, we're going to use select from. And select, I'm using star to say give me all of the fields, but I could specify whatever fields I want. If I said get me the usernames out of this, I could say select username from players and get just the username out of that. I'm going to do star, and then we can work with that data in our data structures once we pull the information out. So I'm going to say give me everything from this table. Yeah, MySQL is still hugely important, but do I need you to understand MySQL coming out of your second semester course? That was a big question I asked myself, and I just don't think so. I don't think there's enough content in this course that I don't need to add. We don't have to rush things too much. That you got another 3 years to get some MySQL experience. Take 312. We talk about MySQL and MongoDB more in depth. So at least setting them up and the structure of it. I want to execute this query, which is expected to return some information to me. So how do we get this information out? Well, executing this query is going to executing a query instead of a statement. Notice the difference. Instead of executing statements, we're executing a query. That's going to give us some information back in the form of a result set. And then we can iterate over this result set to get the information that we need. And then in this case, I'm adding it to a data structure, this map which is going to be username to score, points here. I'm going to add all that information to this data structure. Then I can work with that data structure with all the Scala stuff that we know how to do now, that I don't have to work with SQL. I don't have to think about SQL after I get everything into this data structure. So to do that, result.next is going to tell us if it returns a Boolean, and it tells us if there's more information to read or not. So as long as there's more information to read, I'm going to get the username and points out of that next thing to read, add those to my data structure, and go on to the next one. So each time I call next, I forgot to mention this part. Each time you call next, it's going to advance to the next piece of data that can be read, and it returns a Boolean of whether it did actually find another piece of information to read or not. So as long as there's something more to read, advance to the next thing and populate my data structure with that. $10 gigs of parentheses. If your file's 10 gigs of parentheses, I mean, but that also relies on however they're sending the query to you. You have to have that limited as well. So if your network's broken but your file I/O is not, then yeah, that works. So, or you're just naturally restricting 10 gigs of uploads. So there's one kind of problem with this. I shouldn't call it a problem. Yeah, this is basically 115 again, but in Scala. So I'm not going down SQL. I'm not going to talk about SQL itself. W3 Schools, as usual, has us covered on this. If you want to learn more SQL, learn what you can do with SQL statements and everything. But that's definitely not a road I'm going to go down. Just like we don't go down that road in 115. But we have database courses if you want to learn more about that. there are ways to get that information. I'm not going to do it in lecture. What does SQL return if you try to select something from a table that isn't in the table? It probably gives, I don't know off the top of my head, but if you had like select password from players, I would guess it gives you an error, but I am just guessing there. At the very least, it's going to give you an empty result set, I would expect, or maybe nulls. I don't know. I'd say unexpected. I'd say don't do it is the best thing, but I don't know what the specific error you would get would be. So SQL is based on these tables with rows and columns. You have a table, you set up the columns, and you can insert rows into that table. So this structure is very reminiscent of a CSV file. It's similar in structure to a giant CSV. Well, I guess it doesn't have to be giant, but it's similar in structure to a CSV file. And we had this question when we were using CSV. We have this question when we're using SQL. Is what if we want to store data structures in a column? So what if we want a username and then some column, another column that has some array or key value store of information about that specific user? How would we add that? How would we do that in a CSV file? We have the same question. How do we do that in SQL? So with CSV, our answer, at least in 115, 116, our answer was to move on to JSON and get a format, a textual file format structure that can support different, more complex types of data. And we throw our data in JSON objects, in JSON strings more generally, to be able to represent more complex structure to our data. With SQL, the answer is to create two separate tables and then use joins on a common key, which is something, if you do dive into SQL and want to look at that, joins, that's a topic that's going to come up early and often when you're trying to work with SQL and get things working. Or you can use a database like MongoDB, which is similar to JSON in structure. You give it JSON strings, it'll store that JSON in the kind of JSON structure that we expect, that we've become accustomed to. You could do that as well. It's another option. But if you do want to dive into SQL, especially for the project contributions, you might want to look into joins and creating separate tables to be able to have more data associated with someone. So maybe for a specific user, you want to remember all of their past office hour visits. You would create a separate table that logs each office hour visit and then look up everything in that table with that username every time you want that user's specific history, office hour visit history. You would do something like that. Or you can cheese it and just store JSON strings in a MySQL column. You can have one column that says game state in JSON format, like for the clicker. Clicker, if you want to use actually CSV, I was talking to a student, CSV doesn't work very well for the clicker expansion. You might want to, for that one, I'd actually recommend just coming up with your own file format. You want to store these JSON strings and also the username attached to that string. I would do username, some delimiter that's not going to show up in my game state, like a pipe or something, or maybe a $sign or something, some character that you know isn't going to show up in your game state, and then the game state. And then when you read this file, split on the $sign. Because CSV, you can still use it, but it's tougher to work with because your JSON is going to contain commas and quotes. So you lose your escape characters in CSV. You got to escape all those characters and go through some more stuff that you might not want to go through, or import a CSV library to handle it for you. I thought that was my last slide. Errors? Okay. So yeah, don't do that. So it's not something you can do because your code will just be broken, then you have to fix it. All right, so with that, let's take a look at why can I never zoom in? Oh yeah, I set it to my mouse wheel. So you can see, can't see. I forgot it. I forgot it happens behind the scenes, but we do. should be one of the last ones. We do have to have this in our, this is worth mentioning, I suppose. We do have to add the driver for MySQL to our POM and install that. But when we actually run our code, we don't import that at all. Sometimes you have to do it manually. You have to pull in, sometimes you do have to pull that in. If you're having strange errors, this is one thing to try, is to run these 2 lines of code. But this happens behind the scenes when you make this connection. This connection is going to look for that library to be able to figure out exactly how to connect to this specific database. So that is being used, but we don't import it, which also makes it a tricky error to find. Because if you don't add that to your POM, your code looks identical to my code, but you run it and it just doesn't work if you don't have that in your POM. So I have the code that we saw in lecture, setting this up, making that connection, and then I can start running, well, drop table, don't really need. But for, I was always deleting the table and then recreating it. So there weren't duplicate entries each time I ran this code. And then, doing the things you would expect. And then some testing. If I want to add some players in this database, use my create players method. Oh, here's up. Did this go to a different file? Did I just not keep scrolling? Adding new players in this database. And then updating, one thing that I didn't talk about in the slides. If I want to update values, so I want to update all the values in players. I want to set these values, and I have some condition where I'm going to set them. So I want to update this username. I'm going to say where this username is the username that I was provided. Up in this table, update all of these values for that player. Every time you find that player, then use my prepared statement and set all that values. So if you want to update something in a database, that's the syntax to do that. Then my get everything out of the database methods. So I'm going to create some players. I'm going to check, make sure all that stuff's working the way I want it to. Update Peach and make sure all that stuff updated as I expect. So if I run this, I should get errors. Let's see what specific error it does. It does give. I don't get errors because I don't have MySQL running. So if you just run this code right now, you should get the same error. The database, link failure, database isn't running. Nothing's responsive on port 3306 on localhost. Where is everyone missing out on lecture? You can always drop your tables. Yeah. It makes it a pretty a silly example because I'm deliberately destroying the whole point of using a database in that on every server restart, I'm absolutely destroying all the persistence that we were going after. But if you run this, if I don't have this line and I just run database running example, I want to run it like 3 times. In lecture, I want to make like a small change and then show the difference. And then I'd have all these duplicates in the database is the reason why I'm doing this. But yeah, dropping your tables on startup is just about the worst thing you could do.